Hey there everybody. In this video we are going to discuss the introduction into calculus topics. Some of you may have seen this in pre-calc. We are going to discuss limits. We are going to take it to the limit. Now, what is a limit? A limit is defined as the intended height, so the intended y value of a function. A lot of you initially might think of this as, okay, what's the y when I plug in this x? But that's not always the case, because sometimes we might have an x function that's not defined. What a limit says is as you're on a graph approaching a specific x value, so here the x value is 3. As I'm approaching 3, what is the y value as I get infinitely close to 3? We can come at this thing from the left side, we can come at it from the right side. We want to figure out what is that limit. Now the notation for a limit is LIM, short for limit, as x approaches some c value. So what is that x value that you're approaching? Of f of x, aka the y function, equals some value, and that L will be a number. So what we're saying is our x value is getting infinitely close to a specified number, and that y value should be getting infinitely close to something else. So here I can make the statement that the limit as x approaches 3 of this function f of x is equal to, well, it looks like the closer I get to 3, the y value gets closer and closer to 2. So the limit as x approaches 3 is 2. Okay. Now, we can also say, what if you're coming at it from different sides? In this function, it's not a huge deal, but piecewise functions, it will be. We indicate the left side notation with a little minus sign. You're coming at a limit, you're approaching it from a negative direction, so from the left. If there's a plus sign, you are approaching a limit from the right side. So I'm approaching 3 from the right, approaching 3 from the left. If there's nothing specified, then you are doing what's called a overall limit from both sides. And what we're going to start seeing is we want these two limits to agree to each other, so that way we can claim an overall limit, a two-sided limit. All right. So let's take a look here. We've got a function that looks like it's disjointed, so there's probably some sort of a piecewise. We have the limit as x approaches 4. Clearly, these are doing different things. So as I approach from the left, this little guy driving the blue car, he's approaching a value of 1. So if I approach 4 from the left, right here, 4 from the left, that's a value of 1. If I approach a value, x value of 4, so I'm getting closer and closer to 4, from the right side, this little green car, that approaches a y value of 2. Clearly, those destinations are different. They are not approaching the same value. So this overall limit does not exist. So the limit does not exist. Hashtag mean girls. Now you can have a limit that exists even if the function itself does not. So here I've got an example where the limit as x approaches 2 from the left and from the right, they both have the same destination. Now they don't reach that destination, but they're both approaching the same thing. So here the limit would in fact exist. So you do not need to have a y value in order to have a limit that exists. So let's take a look at a graph here. Here we've got some, again, bizarre, probably piecewise function. We're talking about the limit as x approaches -2 from both directions. And we have limit as x approaches infinity and positive infinity. That's just end behavior. All right. So what I'm going to do is plot a little generic point, and we'll move that around. As x approaches 2 from the left side, it looks like my intended height is 2. As x approaches 2 from the right-hand side, it looks like my intended height is 1, 2, 3, 4, 5. Those two limits do not exist, so the overall limit does not exist. F of -2, if I plugged in -2 for x, I would get this point, which is at 0. I cannot claim either one of these two open circles because they're not defined. My function is not defined at either of these spots for -2. It's defined down here at this point. The limit as x goes to infinity. So if I were to go to positive infinity, continuing forever to the right, it looks like this thing just kind of flatlines, or it's almost an asymptotic relationship. And it's pretty much going to approach that value of, what is this, 1, 2, 3, 3. So the further and further you go out to the right, your limit you're approaching is 3. If we go forever to the left, so for a negative infinity, as x goes forever left, we go negative infinity. This thing is going both down and left, so we are going towards negative infinity there. Now this little note here says limits are DNE. So we say a limit does not exist, but when you talk about function values are undefined. So you don't ever want to say that a function value does not exist or a limit is undefined. Limits do not exist, functions are undefined. Easy way to remember that, UN, UN. All right, continuing on. All right, we are approaching 3 from the left and from the right, seeing if there's an overall limit here. So 3 from the left. So as I approach 3 from the left-hand side, it looks like it's approaching a value of 2. 3 from the right-hand side, it looks like it's approaching a value of 2. Hey, they agree. Oops, I wrote the wrong number. Since they agree, we can claim that the limit as x approaches 3 is 2. Now f of 3, well, I've got a hole in the graph. This function is undefined there. So the limit exists even though that function is undefined. If that was a filled in dot, well, then it would be a different story. What about vertical asymptotes? We have as x approaches 2 from the left and from the right. So as we approach 2 from the left, it looks like it's going down forever. So that'd be negative infinity. As we approach it from the right, it looks like it's going up forever. Well, that's positive infinity. Those don't exist, don't agree. So that overall limit does not exist. F of 2, since it's an asymptote, is undefined. Next one. Right and left hand and behaviors. As x goes to positive infinity, forever to the right, we are approaching a value of 1. If we go forever to the left, we're approaching a value of 1. There's a horizontal asymptote. F of 1, when x is 1, what is the f of x value? What is the y value? Well, that is 0. Let's talk more about vertical asymptotes here. We have, as x approaches 3 from the left, that's going up forever. As x approaches 3 from the right, it's going up forever, positive infinity. Those things agree. So the limit as x approaches 3 is positive infinity. Even though that function is not defined, f of 3 is undefined. The limit as x approaches positive infinity is 0. Negative infinity is also 0 because we have a horizontal asymptote at, you guessed it, guys, 0. All right, and we'll go ahead and end on this one. There will sometimes be scenarios in which we have an absolutely bizarre looking graph, but we can draw conclusions based on the patterns that we see. Here we have some sort of function. It looks like it swoops in from up above, and then it starts to oscillate back and forth, back and forth, back and forth, and it kind of gets smaller and smaller and smaller with that amplitude. If I were to have a limit as x goes to negative infinity, if we go forever to the left, based on what I'm seeing from this function, it looks like that graph is going forever up and to the left, up and to the left. So since it's going up, we would say that goes to positive infinity. However, as I go to positive infinity for x, I'll really zoom in here, it looks like this function is just getting tighter and tighter little squigglies. And it's just hugging that little dotted line closer and closer and closer and closer and closer. That dotted line, allegedly, is y equals -2, so the limit would be -2. All right, that is all for this video, folks. You know the drill. If you have any questions, feel free to ask. And as always, good luck, have fun, be safe, roll tide.